Have you ever just stopped and noticed that, well, everything seems to be spinning? It's not a coincidence. It's actually a clue, a hint to one of the deepest, most beautiful truths in all of physics. So let's pull on that thread and see what we unravel. It all starts right here, at home. As you're watching this, yes, you, are hurtling through space at about 1,000 miles per hour. We're all just along for the ride on this constantly rotating planet of ours. Now, let's zoom out a bit. Our entire solar system is on this epic 225 million year road trip around the center of the Milky Way. Our galaxy is just this vast cosmic pinwheel with hundreds of billions of stars all spinning together in a silent dance.
And if we zoom all the way in, way down to the quantum level, it's the exact same story. The electrons, the protons, the neutrons that make up every single atom in your body, they have a fundamental property that's literally called spin. So from the absolutely massive to the unbelievably tiny, our universe is just in constant spinning motion.
So, okay, we've got to ask the big question here. This can't just be random, right? If everything everywhere is spinning, there has to be a really deep reason for it. So where did all this cosmic motion even come from in the first place? To find that answer, we first have to just fully appreciate the scale of this cosmic dance. Seriously, look anywhere in the universe and you'll see it. You've got planets orbiting stars, stars orbiting the centers of galaxies, and even whole galaxies wheeling through the empty void. In our universe, rotation isn't the exception. It is absolutely the rule. Okay, so how does something keep spinning for billions and billions of years? Well, the immediate answer, the how, lies in a principle that you've definitely seen before, even if you didn't know its fancy physics name. And that principle is called the conservation of angular momentum. Now, it sounds complicated, but think of angular momentum as just a number that tells you how much spin something has. And here's the crucial part. Unless some outside force comes along and messes with it, that number can't change. It has to be conserved. It's a fundamental rule. And this is the perfect way to picture it. You've seen a figure skater do this, right? They start a spin with their arms stretched way out. Their mass is all spread out, so they spin kind of slowly. But then, bam, they pull their arms in tight. All that mass gets closer to the center, and to keep that angular momentum number the same, their speed has to go way, way up. The universe does this exact same thing, just on a slightly bigger scale. But that just explains how spin keeps going. It doesn't tell us the deep reason why angular momentum is the thing that's conserved in the first place. For that, we have to go to one of the most powerful and frankly beautiful ideas in all of physics. The great physicist Richard Feynman put it perfectly. The universe is woven together from these really deep, simple rules. And the conservation of spin isn't just some random fact, it's one of those threads. And when you pull on it, you start to see the whole pattern of the cosmos. And that rule, that deep thread, is called rotational symmetry. It sounds complex, but it's an idea you already understand completely. It just means that the laws of physics, gravity, light, everything, they work the same no matter which direction you're facing. North, south, up, down, it doesn't matter. Space has no favorite direction. And this is where it all comes together. This is the big aha moment. Thanks to a revolutionary theorem by the brilliant physicist Emmy Noether, we learned something truly incredible. You can see it in this table. Every fundamental symmetry in nature is directly locked to something that must be conserved. So, the fact that physics doesn't change from moment to moment, that gives us conservation of energy. And here it is, the big one at the bottom. The fact that space has no preferred direction, that rotational symmetry, is the one and only reason we have conservation of angular momentum. Things keep spinning because the very fabric of space gives them absolutely no reason to stop. How cool is that? Okay, that's amazing. So angular momentum is conserved because space is symmetrical. Got it. But wait, if it can't be created from nothing, where did it all come from? How did the universe get all its spin to begin with? Well, the origin story is just incredible. It all started way back at the Big Bang. At that scale, quantum mechanics guarantees that nothing could be perfectly, absolutely still. There were always tiny, microscopic, unavoidable wobbles and jiggles. Then gravity started doing its thing, pulling these enormous clouds of gas and dust together. And that's when the figure skater effect took over. As those clouds got smaller and smaller, those tiny, insignificant little wobbles got amplified into the powerful, majestic spins we see all around us today.
And the numbers here are just mind-bending. Get this, a giant gas cloud, maybe a light year across,
might have an initial rotation so slow it would take 1 billion years just to make one turn. But as gravity crushes it down to form a star, the conservation of angular momentum can speed that up to multiple rotations per day. That's the staggering power of this principle.
So this is a beautiful cosmic story for sure. But what does it have to do with us here and now? Well, as it turns out, this cosmic dance is woven into every single part of our existence. I mean, really think about your connection to all this spin. The iron in your blood, the calcium in your bones. Those atoms were forged inside spinning stars and then thrown out into the cosmos. Our entire solar system is a flat disk because that original spinning cloud had to conserve its angular momentum as it collapsed. Our cycle of day and night, that's a direct result of Earth's spin. And on the most fundamental level, the spin of electrons is what dictates all the rules of chemistry, making stable matter, and you, possible in the first place. So the next time you look up at the night sky, remember that all that spinning you see, the moon, the planets, the stars, it's all the visible evidence of a deep, invisible symmetry woven into the fabric of space itself. And it really makes you wonder, doesn't it? What other profound cosmic rules are hiding right there in front of us, just waiting for us to notice?